Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams PFM, IFM, and LTAM that I offer. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help-ISU actuary. Here's a problem for today for exam P on probability. You are the actuary in charge of purchasing a reinsurance contract for your insurance company. You have determined that the losses that you want reinsured follow a uniform distribution on the interval from 1,000 to 2,000. You have a choice of two reinsurance contracts for these losses. The first contract will pay 90% of the loss, while the second contract will pay up to a maximum limit where the limit is set so the expected payments for both contracts are the same. Find the ratio of the variance of the reinsurance payment under the second policy to the variance of the reinsurance payment under the first policy. And here's the solution. So let us write X for the loss amount. Under the first contract, the expected value of the payment is 90% of the mean of X. So of the uniform distribution on 1,000 to 2,000, so 90% of 1,500 or 1,350. The variance of the payment under the first contract is the variance of 0.9 times X, which is 0.81 times the variance of X, which is 0.81 times 1,000, the length of the interval from 1,000 to 2,000, squared divided by 12. That's the variance of uniform distribution. And that ends up being 67,500. Let us denote the policy limit under the second policy by M. The expected value of that policy payment is the interval from 1,000 to M of X times 1 over 1,000. 1 over 1,000 is the density of the uniform distribution we're working with. And note that for any loss amount less than M, payment equals to the loss, and expected value calculation is done under uniform distribution. And then M times probability that X is greater than or equal to M. For any loss amount of M or more, payment is M, and the probability of loss exceeding M is probability that X is greater than or equal to M, which is 2,000 minus M over 1,000. So the first integral is equal to the integral of X over 1,000, which is X squared over 2,000, evaluated from X equal to 1,000 to X equal to M. And the second expression is equal to M times 2,000 minus M over 1,000. And that ends up being equal to minus 0.0005 M squared plus 2M minus 500. But this must be equal to 1,350. So 1,350 is equal to minus 0.0005 M squared plus 2M minus 500, resulting in the equation 0.005 M squared minus 2M plus 1,850 is equal to 0, so that M is a solution of a quadratic equation that we see here. We use the quadratic formula, we solve it, and we get two answers. One is 2,547.72, and the other one is 1,452.28. Since the limit should not exceed 2,000, the maximum loss, M is 1,452.28. And we find the second moment of the payment under the second policy as the integral from 1,000 to 1,452.28 of X squared times 1 over 1,000 dx plus the payment now, the maximum M is 1452.28. That's the amount of the payment squared times the probability that X is more than 1452.28. So this ends up being x cubed over 3000 evaluated from x equal to 1000 to x equal to 1452.28 plus 1452.28 times 0.54772, and then we calculate all that and end up with 18,428,812. Then the variance of the payment of the second policy is that second moment we just calculated minus the square of the first moment, and that's approximately 20,382. The ratio of the two variances is 20,382 divided by 67,500. That's approximately 0.30, which is answer E. Please remember, this is copyrighted material. The problem was created by me, and the solution is mine. All rights reserved. Reproduction in whole or in part without express written permission from the author is strictly prohibited.